But it's fair to say that you're working with Gigacastings, right?
Sure, we do.
It's fair to say that you have signed NDAs that probably will throw you in jail if you reveal too much.
Yeah, we have signed NDAs anyway, if I say like that.
Yeah, we have signed NDAs, and I hear multiple, plural. Is there a common question from the OEMs to you when it comes to Gigacasting?
Another topic that we really haven't touched yet so far is also the fact that when using Rheocasting, we also enable the usage of a smaller die-casting press, so to say, from a locking force perspective. I think this is one very common question. How much smaller die-casting press are able to be used, so to say. Another topic is, of course, the alloy. What alloy should these huge castings be casted with in order to achieve the best possible properties? And then, of course, again, we also have the sustainability discussion that is also something that is coming more and more.
You mentioned a few things now in the last sentence. Yeah. I think we have to go into each of them individually. Let's start with the machine size reduction. So we all know the larger the machines, the costs are going exponentially up. Now it's the interesting thing, how much can you reduce the machine? Yeah. Do you have some numbers there?
Yeah, that is of course very much dependent on which castings you are going to cast. But as an example, we have casted a casting with a very long flow length, 2.2 meters as mentioned earlier. The projected surface on this shot is approximately 33 square decimeters. And we casted that in a 600-ton die-casting machine with roughly metal pressure, I would say around 200 bars, something like that. Where we also obtained very even properties from the beginning to the end of the casting, and also a reduction of porosities compared to liquid casting with about 50%. Whether these numbers can be transferred directly into a large mega casting is something I can't really answer without have the experience of doing it. But as you understand...
But isn't that the problem, that no one has experience?
No.
It's a new part.
But I once learned a rule of thumb when I started in this industry 30 years ago. It's roughly, if you want to make a quick calculation in how big die-casting machine that is required, calculate about 100-ton locking force for each square decimeter. So that tells us that this large casting that we made in a 600-ton should be equivalent to roughly 3,000 ton, but it's made in a 600-ton. Whether you can go that big drop, that is yet to be proven.
It comes down basically more to the tie bar distance.
Basically. Let's say that with Rheocasting you get a very high yield on your machine table.
But with your experience of these projects then, what do you see as the biggest problem that the OEMs have with their Gigacastings?
I mean, we talk about the automotive industry, and we all know how the automotive industry is when it comes to quality and uptime and efficiency and so on. I mean, it is probably the world's most competitive market to be in, meaning that the uptime, quality output, and the ability to plan. I think this is the biggest headache when it comes to these large machines. I mean, you need to be able to plan how often should I take down the shot sleeve due to wear? How often do I need to take down the die in order to make my maintenance and so on? And know that this is the fact. And I think the one that has the longest intervals here has a huge advantage. And also knowing that the output is what we have planned the output should be.
What you just described makes me feel that this should be a Japanese sport rather than a sport in other countries.
I mean, they are very good in this. If we look at the Japanese, how they face quality and all this, and they are very structured and so on. So I'm sure that they will be very good when they apply these tools that they have developed over the years also onto this technology.